So before we start chapter 18, we need to know some key vocabulary related to circles. So with these pictures, I've covered up some key vocabulary with the white yellow boxes here, so we can see what these are. So this distance here is referred to as the arc length, and we have a small part of this and a large part of this. So the large part is referred to as the major arc, and the small part is referred to as the minor arc. Now, the parts that are shaded here, these ones often get mixed up. This one here is called a sector. As it's the small part, this is the minor sector, and then the large part would be the major sector. And this part here, when we draw a chord across here, then this is referred to as the major segment. This is referred to as the minor segment. So we need to make sure we know those terms from geometry before we progress. Now, while we're doing this, and you can see those pictures a little clearer now with some of the vocabulary listed, we're going to refer to arc length as S, and we're going to refer to the area of a sector as A. And then with that, there's a couple of formulas that go with this. So if we want to find the arc length, we're going to use S equals R theta. R is your radius. And if we want to find the area of a sector, then we're going to do a half R squared theta. Importantly for this, theta must be in radians. So make sure you know how to change your calculator from one mode to another mode. Radians to degrees, degrees to radians. It should have been covered in another class, but we're going to look at it one more time. Also, what is a radian? Well, it's a unit of measurement for angles. And the definition is, this will be 1 radian here, assuming I can draw this accurately, and it's where the length of the radius equals the arc length. And when that happens, the angle it produces is called 1 radian. And it happens to be about 57 degrees. Now, we should also know that pi radians is 180 degrees, and this is actually where 1 radian comes from. If we divide both sides by pi here, this is actually 180 divided by pi in terms of degrees. Now, if we're going to switch between the two, this big fact here is going to be very helpful to us. So if I want to change from degrees to radians, most people think of radians as something with pi. So we times by pi over 180. Notice that fact from earlier, pi radians equals 180 degrees. So if I start with 80 degrees, times it by pi over 180. If you simplify here, all we need to do is simplify the fraction. If you've got a good calculator, it'll do it automatically. Divide both sides by 10, and also I can see a factor of 2 here as well. Oops. So we should end up with 4 pi over 9. We can also do these questions in reverse as well. We can go from radians to degrees, and we're just going to do the opposite. So instead of times it by pi over 180, we divide by pi over 180, or times by the reciprocal, which is 180 over pi. Simplify, simplify. The pi's will cancel, and we just have 900 over 600, which is 150 degrees. So very easy to change between those two forms. Now we can also be asked to find the area of a segment, which is what I've got shaded here. So I've given you the radius, given you the chord length, and now we're going to try and figure out how we're going to find this shaded area. Well, notice it's actually 2 parts here. It's actually a sector with this triangle removed. So we're going to use that fact to help us. Now the area of a sector we already talked about. We know how to find the area for that. The area of a triangle, perhaps most naturally you'd think of a half base times height. Notice you don't know the height for this though. Now we could work this out using Pythagoras, and then we'd be able to do that. And there's also an alternate way we can do this. The area of a triangle, we can actually use a half AB sine theta. Now we don't actually know theta for this question, but also we don't know theta straight away anyway for our sector. So that's going to be something that we're going to need to work out. So the area of a triangle I said was a half AB sine theta. Notice that the A and the B though are actually both radiuses. So we can also write it as a half R squared sine theta. Both of these terms have half R squared as a common factor. So this is a formula I'd recommend you actually learn if you want to find the area of a segment. R we're given in the question. What we don't have though is theta, and so we're going to have to try and work that out. Well, you could use the cosine rule if you can remember that, but that's quite a long formula, and that's not on the formula sheet. So we might want to resort to using a little picture. If we take that triangle and then split it in half, we can work out this angle here by actually using trigonometry, so opposite over hypotenuse. I've called this angle alpha because actually the angle up here is the full angle, so this is just a half of that angle. Inverse sine for this question, but make sure you're in radian mode when you're actually working this out. And then once you found out what that angle is, double it, and that will actually tell you what this angle is up here. And then you can go ahead and substitute into this formula here to find out what the answer would be. So when you're doing an area of a segment, make sure you're using that formula. Once again, just a reminder, theta must be in radians, so make sure your calculator is in the correct mode.